Hello everyone. So we have completed unit 1. Now we are going to start the unit 2. In the unit 1 we discussed about the big data concepts and what are the solutions for handling the big data, and also what are the distributed systems available which is suitable for the big data handling. So Google and Hadoop are the distributed systems which are popular, and Hadoop is the open source framework for distributed handling of the data. So in that we discussed about the distributed systems, right? And now in this unit, this is completely based on the HDFS concept. So in this unit we are going to discuss about what is HDFS, Hadoop Distributed File System, how can we store the data into that, and how to load the data and how to manage it. That is also by using some HDFS shell, and also by using some APIs, how to access the data into HDFS. So these concepts will be covered in this unit. So as a part of that, in the first session, we are going to discuss about the HDFS architecture. Now in this, so we have completed all these concepts, and distributed storage and distributed processing we have to discuss about these two topics. And then Hadoop ecosystems. What are the ecosystems in detail? In the last unit we discussed only as the overview. Here we are going to discuss what is that clearly little bit. And HDFS architecture, we will start the HDFS architecture also as a part of this session. Now distributed storage and distributed processing. If you have these two concepts, distributed storage and distributed processing, then you can achieve the goal for most of the problems. Can be solved. So here the distributed storage, let us concentrate on the distributed storage. Now in this we have the number of machines available. All these machines are the servers only. They are not the client server architecture. All these are the servers. If you have the data of 150 MB file, let us say, that 150 MB file has to be distributed over the cluster. We can call it as a cluster, collection of machines. How can we distribute the 150 MB data? That can be divided into several parts. So see here, in this we can divide the data, 150 MB data, into 64 MB as the first block, and that can be stored in one machine, and next 64 MB can be stored in another machine, and remaining 22 MB that can be stored in another machine. So that 150 MB file is going to distribute over the available machines. So this is the distributed storage. And now we are going with the distributed processing in brief. Now process. Even if you have distributed the data into various systems, still we have a problem, that is the process. Now see here, there is a process initiated. Generally if you start the process, that will be initiated in one machine only, so that, let us say for example, the initiated process is here in this machine. So this process can access the data from here easily. But what about this data? Now this data has to be transferred into this machine, meaning that the data available in another machine, that has to be copied into this machine over the network, and then it can be processed by the initiated process. In the similar way, this data has to be also transferred over the network. So here there are two problems. One is you have to transfer a lot of data over the network, so that it will consume the bandwidth, lot of bandwidth. So that is the first problem. And the second problem is, here we are taking just 150 MB data. But instead of this, if you have 2 terabytes of data, if you want to access and if you want to process 2 terabytes of data, how can we handle that? How can you process and how can you hold that in a single machine? It is not possible at all. So we have to find the alternate. That alternate is the, instead of taking the process at one machine, it is better to copy the process over the different machines, over the cluster on different machines, instead of shifting the data from one place to another place. So the data may be very huge. It may be in terabytes or gigabytes, terabytes or petabytes also. But the process may be in the KBs only, maximum in KBs or MBs. So the process can be transferred very easily to another machines, so that we can copy the process onto different machines, all the machines wherever the data is available, and this process can operate on this data and it will produce some output. This process can process this data and produce the independent output. This will also produce another output. Now we have to aggregate these three outputs. So for that we should have another process. So this process will aggregate the outputs of all other processes. So this is the idea of the distributed process. Instead of executing the process at one machine, we can go with different places. We can execute the process on different places where the data is available, and then we can aggregate them. So this is the distributed process technique. Now we can go with the various Hadoop ecosystems, Hadoop and Hadoop ecosystems. As you know, the base concepts of the Hadoop are the HDFS and MapReduce. The HDFS is the distributed file system that runs on the large cluster of commodity machines. Here the commodity machines mean regular machines, whatever you are using, the regular desktops and laptops. On those machines you can install the HDFS, and the main purpose of the HDFS is the huge storage. You can store the large amount of data in the HDFS. And there is another method. If you have the storage, there is no use. You have to process it. For process, you have the MapReduce concept. The MapReduce is the distributed data processing model and execution environment that runs on the large cluster of commodity machines. Again, it is also the commodity machines. Now you have to remember that this is a separate cluster and this is a separate cluster. And we can install these two on the single environment, that is on the same set of machines, so that these two can work together. So here the MapReduce will take the data from the HDFS and it will be processed and it will produce the output. So this is the MapReduce concept. Of course the output can be also stored back in the HDFS only. And now Hadoop ecosystems, other components of the Hadoop. Now here Pig is another component. Actually, if you want to write the MapReduce processes, it is heavy load. And one more thing is, it is the complex system. Meaning that if you want to write the MapReduce component, then you should know, the programmer has to understand the Java components and how to write the program, and all these are very complex structure, and also there is no reusability also of the code. It is limited reusability is also there. So we should have some abstract level of the programming for the MapReduce. That abstract level of the programming, that is by using the Pig. So here Pig is on top of Hadoop. You can understand easily by using this diagram. Pig is on top of Hadoop. Hadoop is the HDFS and MapReduce. So see the definition: a data flow language and execution environment for exploring very large data sets. And Pig runs on top of HDFS and MapReduce. And now another environment is also there. If you are a database programmer, if you are comfortable with the databases, then we have to go for the databases concept. Now here also we have one environment, that is Hive, data warehouse environment. Hive is a distributed data warehouse environment, and it manages the large storage of data, large data which is stored on the HDFS by using some queries. If you write a query, that will be converted into the MapReduce application, and that will be executed on top of the HDFS. So this is the Hive concept. So these two are on top of the Hadoop only. Now we can go with the other ecosystems. Here we have the databases. From number of decades we started using the databases, and large amount of data is available in the databases. Still we are using the databases in the so many organizations. So if you want to get the data from the database, and if you want to access that into HDFS, then we have to write a program again. Again you have to write some MapReduce program to load the data from the database and store it in the HDFS. So this is a little lengthy process. And instead of that, we have a tool available, an interface, that is Scoop. The Scoop is a tool designed for efficiently transferring the bulk of data between the Hadoop and the any other relational databases. Relational databases means it may be the Oracle, MySQL, any databases. Okay, so it is an interface between these two. And another use case is here we have large amount of streaming data. Let us say, for example, your WhatsApp messages, Facebook updates, Twitter, all these are the streaming data. Of course, stock market and weather analysis, all these are having the real time and streaming of the data. And we may have the log files, large amount of log files. So if you want to handle these two, it is very difficult. How can we store them into HDFS? This is a little tricky. Now for that also we have a separate tool called Flume that can manage the streaming of the data. It can collect the data from stream and also the logs whatever generated, and they can be stored in the HDFS. Of course, Flume can be used for different purposes. The basic purpose is to take the data from the stream and also from the log files and store that in the HDFS. So these are the various components or ecosystems of the Hadoop. Now we have to start with the HDFS, that will be in the next session.